This is Foresight Opinion, the voices behind the energy transition.
My name is Chris Janson. I work in Nokia's solutions marketing group, and we spend a lot of time looking at mission critical enterprise networks and trying to provide clarity to our customers and how our solutions map into their business goals and objectives.
I'm Raaflaub. I serve as Director of Solution Marketing at Nokia, helping our service providers and our partners kind of drive network infrastructure leadership in the marketplace.
Fiber sensing is an interesting development or evolution of what we once called fiber monitoring. And I think this is a very important definition that's sort of changed or evolved. And for as long as we've built fiber optic networks, we've tended to monitor sort of the performance across the network, looking at optical power and how it might change. And then when something goes wrong, trigger an alarm and take action. What's happened now more recently in this idea of fiber sensing is providing kind of continuous diagnostic analysis of what's happening in the fiber plant. What I mean by that is now we've gone to a more dynamic situation. So fiber sensing gives us the ability to do a whole host of new things beyond just reacting to something very bad.
Absolutely. Like, especially if you look at a power utility, they have several key imperatives with running a network and modernizing the network. And four key ones are like having a network that has high availability and survivability. We all know that when we click the switch on the wall, we expect 99 point many nines that the light will come on. Fiber sensing points to helping them with that goal. They want and require networks that are very deterministic. The equipment they have in substations and on their poles really require very accurate information, timing and jitter and things like that. And fiber sensing helps them sniff out when that might go a little awry. And then, like everybody, in telecom and utility, just honestly, just across many industries, it's all about lean operations and automation. And fiber sensing really helps streamline a lot of heavy resource intensive activities. And then there's just security and compliance. We don't want bad actors messing with our utility networks and the power grid, and fiber sensing touches that as well. Yeah, like Chris, high availability and survivability. What's your thoughts on that? I think utilities got power lines, they've got optical cables, and those don't need to be broken, right?
Indeed. Again, this is going beyond just monitoring and truly using the word sensing. So what could go wrong in a network? And imagine that power utility uses their fiber optic network to monitor and control ultimately the power grid in one way or another. So the sooner they can tell that something might be going wrong, the better. So if for example, they can tell that there is a backhoe or some construction equipment getting closer to the fiber, not just actually breaking it, but actually getting closer to it, and can sense that there's something abnormal, then that's better for them. That means that they can detect that something's potentially happening and then take action before it actually affects the power grid's operation. So there's really a real element of operational efficiency, customer reputation, and cost control here that can be realized as a result of truly using the fiber optic cable as a sensor rather than just a communication means.
That's right. And the accuracy of these next generation technologies, the ability to use what we call kind of coherent optical, that's kind of next generation optical technology that, pushes ones and zeros much faster and more of them, more bits down that fiber. That same technology really allows them for some incredible sensitivities regarding sound, vibrations, just seismic waves, changes in temperature. So, some of the things that you framed, Chris, that, there's some really good things, not just knowing when the tractor pulls up over top of the fiber. It goes right to like security, hearing someone open a door or someone walking in a substation. It can feel those 1 kilohertz sensitivities, which is amazing.
It's truly amazing. Just to give a sense without too much technical detail, but again, we've evolved from just monitoring an optical power on one end of a fiber optic transmission link to then using what they call backscatter. So this is the idea of, it's almost analogous to radar, where you send a pulse down the piece of fiber and then look for a response. And this is how an optical time domain reflectometer, a well-known piece of optical equipment, works, diagnostic equipment. And that capability has evolved very significantly. So one can detect where a fiber break is or degradations occur down to within a matter of a few meters. And that's this idea of backscatter, but it's evolved beyond that. It was what Kurtz was alluding to, which is sometimes called what's called feed forward. So the idea now that I can actually look through an optical link, detect changes in the optical phase as well as amplitude, and as a result of that, I can make some really, really couple that together along with some significant digital signal processing power, to say nothing of AI. So with all these things together, I can make some really, really significant conclusions about what might be going on along that fiber link. So all of that, here's a really interesting scenario that Kirk sort of mentioned, right? The idea of being able to detect certain frequencies adjacent to the fiber, meaning frequencies, meaning sound frequencies. So if we can actually use a fiber optic cable to detect someone talking adjacent to a fiber cable in a place where maybe they shouldn't be, then all of a sudden I've got kind of a security sensor. So imagine a fiber cable coming into an equipment hut of some kind, and we're out of operating hours, and we know that there's no one performing any work in that fiber hut, in that equipment location. Well, then I say, okay, something's going on wrong there, and we send the police in. And so we can actually detect voices, we can detect footsteps, we can detect someone snapping their fingers because of the frequency that snap represents. So it's really quite fascinating, quite powerful.
Yeah, Chris, you mentioned AI as well, right? So we're kind of have this intersection of having the optical technology to do these amazing things at the accuracy, but yeah, having AI intersect that and have the ability to machine learn what these sounds and vibrations actually mean, that really kind of elevates the power of the solution.
Fiber sensing has made immense advancements over the last few years, but again, there's nothing new to it. And I'm using the word sensing very carefully, with adjacent, if you will, to monitoring. We've been monitoring fiber links for as long as they've been fiber links. We've now gone into a realm where we're truly using them as sensors. Now, that said, the idea of using fiber optic cables as sensors has been around for several decades, and I'm aware of for example, a company that was trying to use fiber optic sensors about 25 years ago to monitor the state of health on drive shafts on naval ships. At that point in time, it was really far too new. Now, fast forward to 2026, and here we are, and it's completely within the realm of possible to use a fiber optic cable as a sensor. And you might ask why, what's really changed? So a couple of things. The idea of being able to build coherent optical receivers is commonplace now. Not only is it commonplace, it's actually pretty, the costs have come way down. So it's really quite practical. Now, couple on top of that, advances in digital signal processing. So I can take this raw data that might just be simple shifts in, say, polarization of light or backscatter, little photons coming back across a piece of fiber, and I can do something with them. I can process this information. So that's been an advance. The even more recent advances are being able to apply, AI to it. So now, hypothetically, imagine again my scenario of a fiber hut and someone coming in and out, and we can detect the voices or finger snap. Well, now I might be able to, I will be able to learn over time when that's a normal occurrence. Perhaps the fiber hut's adjacent to a busy street, and there's often people walking by, and I can sort of null that out. Perhaps I know that there's maintenance crews coming in and out at certain times, or there's a work order to perform some kind of maintenance, so I can null that out. But now, if something occurs outside of any of those norms, I know more accurately when to actually trigger an alarm. So it's just an astounding set of advancements.
Yeah, no, absolutely, Chris. I mean, and again, outside utilities, probably one of the bigger drivers is just subsea networks. Those networks are so important and so hard to repair, hundreds of feet underwater, and they typically are lifelines for many countries. So any advanced threat warning of a construction or an anchor or a fishing net or just, sabotage is so important. And those tools have been in place, and they're just, as you said, we're just getting better and better. This stuff's been around for many, many decades, but we're getting better and better. And Nokia itself, and our next releases of our products are elevating the ability of the accuracy and viability and value proposition of these great solutions. Yeah, on regulatory, probably not so much on that part, but these type of solutions require next generation optics. So any entity, whether it's internet service provider or a power utility that's using 10 or 15-year-old optical networking technology, that it's doing its job today, but if you want to get to the next level, modernizing your kit, that could be an obstacle for some. But you're getting more than just fiber sensing when you do that. I mean, data centers are coming, the AI super cycle, so much more bandwidth is required. So these optical network solutions are organically getting upgraded. But yeah, to me, the only obstacle would be somebody that's opening up their central office or their substation and looking at a 15-year-old piece of equipment. Fiber sensing to its nth degree may not be coming their way anytime soon until they modernize.
Yeah, I mean, just to build on that, it's true. Some mission critical networks really want to sweat out the value of an asset. So okay, fine. That means that adding these capabilities waits until that modernization cycle occurs. But frankly, once it's there, and what I mean by that is once the utility has taken a decision to modernize a particular part of their network, they really ought to be looking at adding this capability in, because I'm going to dare say that the incremental cost is not so much. And what I mean by that is incremental to performing the upgrade. It's not like this is a huge amount of additional hardware or software capacity. These are the beauty of this thing is that the broad data to do this sensing job, it's fundamentally right there in the fiber optic receiver transmitters at this point. Now that's easy for me to say. Certainly there is some processing, there is some software work that needs to occur, but that's become in a way a simple matter of evolving that or developing that into the capabilities already resident within the systems. So once we had the ability to detect these parameters, these impairments on the link, and then make use of them with pretty powerful signal processing and artificial intelligence, the incremental cost really is quite reasonable.
Yeah, absolutely. So, I mean, if a power utility's aim is to deliver safe, reliable, affordable energy while modernizing the grid to address, renewables and regulatory, decarbonization type of things. Yeah, why would you not want to protect that investment, streamline that modernization through the value proposition that fiber sensing can give you? Again, it's just all about just helping utilities accelerate this, grid modernization, and AI opportunity capture, right, Chris? I mean, utilities' main job is to, power and light our homes and businesses, but they have a very good opportunity to help out with the AI super cycle, because they've got the power, they've got all this fiber that can be leveraged for data center builds and inferencing and things like that.
It's certainly reasonable to say that adding fiber sensing to a network design is not consuming a significant amount of the data capacity on the network itself. In a sense, this is in the background. The fiber sensing capability, this is again part of the beauty of it. We are making use of metrics, of performance metrics, of ultimately impairments or different characteristics, if you will, of a fiber plant, and then performing just a little bit of processing on them. By a little bit, I mean there's not a lot of transmission of sort of adjacent data to perform or reach these conclusions. So there's really no load put, if you will, on the network to realize this thing. Becomes really a matter of I'm just going to simplify it, a few pieces of hardware that might get added to a fiber optic terminal, which are then supported by the overall management system of the network. And so I don't want to say that it's trivial, but it will become, I believe, just an inherent additional feature to these fiber optic systems, to these optical transmission systems. And it becomes a matter of the utility's decision of what they want to do with it, based on a set of capabilities that Nokia will offer them to perform with the sensing platform, I'll call it.
Absolutely right on. It's less to do with, there's more data. It's more of what we're doing with it and how we're working with the data. We're collecting data that's more accurate, and then we have the ability to make it actionable and insightful. It's less to do with the data itself, the size of the data.
It's almost like I want to say if I were a network designer or engineer or decision maker at a utility network, I can't imagine why I would not deploy fiber sensing moving forward. Product availability, roadmaps, and things like that aside, if I'm making an investment decision now on an optical network that I want to operate, I'll say for at least 10 years, maybe even a longer time frame that they look at for these things. What do I consider? Certainly capacity, flexibility, latency, security of the network itself, but then also all the things we've been talking about. How can I use the fiber plant even beyond just for transmission and control of the fiber grid? So I can use it as this broader security tool in a way. And so we can actually go so far as to say that with the fiber sensing capability going down a utility right of way, I can actually monitor that entire right of way, and with AI, learn sort of what the normal sort of ambient background is of things happening on that fiber route, and then create a security facility. I also word it using my communication network. So that's a tremendously powerful thing, and I would really advise or hope that a utility will be looking at this moving forward as a way to do even more with their networks.
No, absolutely, Chris. I mean, just the fact that we're getting the ability to have higher and higher sensitivity and more precise localization. Anytime we talk about those things with a utility, so many have put their hands up and say, if you need a first customer, I'll be your guy, because the value proposition. Remember too, it's becoming more interoperable. They work with both pluggable and embedded optics, whether the fiber's terrestrial on land or subsea in the oceans. And remember too, this does not impact live traffic. There's really no compromise here, other than potential, as you said, adding a bit of hardware to help drive the sensitivity and precise localization. So yeah, this is definitely a pretty cool feature.
The views expressed in this piece are not necessarily held by Foresight Climate and Energy. Original music by Mute Island.